Hey everyone, you're watching the Space Channel. In recent years, there has been constant discussion about sending humans to Mars and the possibility of colonizing the planet in the future. Since the American program is the most advanced, I'll focus on that one. The first challenge to colonizing Mars is delivering all the necessary equipment there, and, of course, the colonists themselves. To solve this, engineers need to tackle a whole range of tasks. First, we need to develop a rocket that can put massive payloads into orbit at a relatively low cost, because we'll need to send hundreds of tons of equipment. Several companies are developing super heavy lift rockets that could be used to send humans to Mars. The first worth mentioning is Starship, created by Elon Musk's SpaceX. This rocket is designed to deliver 100 to 150 tons of payload to low Earth orbit and could be used for missions to both the Moon and Mars. After multiple tests, Starship achieved its first fully successful flight with controlled splashdowns on June 6, 2024, and the program continues to evolve. Starship also has a serious competitor, a long-running project from Boeing, the SLS Space Launch System, which is being developed for NASA. It can place up to about 131 tons into low Earth orbit. Its primary purpose is to support the Artemis and Lunar Gateway programs, and it could be used for future Mars missions. SLS already flew the uncrewed Artemis 1 mission from November 16 to December 11, 2022. The crewed Artemis 2 is currently targeted no earlier than 2026. However, reaching low Earth orbit is only half the battle. After that, the crew faces a journey of about 225 million kilometers to Mars. Using today's rocket engines, that trip takes around 9 months. Data from probes show that over this period, a person would receive a significant, but not necessarily fatal, dose of radiation, with the highest exposure during transit rather than on the surface. So it's in our best interest to cut the travel time as much as possible and improve radiation shielding. Building a nuclear rocket engine is one way to speed up the trip. The idea isn't new, and in recent years, NASA and DARPA worked on the Draco nuclear thermal propulsion concept. But the program was canceled in 2025, pushing any flight demonstrations further out. Because of this, for the first crewed missions to Mars, the plan is to rely on enhanced radiation protection for spacecraft, which reduces payload by 10 tons or more. A lot, given the need to carry extensive life support systems and large reserves of food, water, and air. When the first humans reach Mars, they'll still need to descend to the surface, requiring a lander. Currently, there's no human-rated module flying that can safely deliver people from Mars orbit to the ground. The issue is that Mars, unlike the Moon, has an atmosphere that's too thin for purely aerodynamic braking, yet too thick to ignore. Space agencies have tested various landing schemes for robotic missions, but those won't work for humans at scale. The leading idea is a propulsive landing using rocket engines for final slowdown and attitude control. In parallel, NASA has demonstrated a new approach, an inflatable heat shield, Loft ID, which was flight tested successfully in 2022 and could enable heavier landings on worlds with atmospheres. Using an inflatable structure made of ultra-strong materials can significantly reduce the mass and size of heat shields compared with traditional designs. The first astronauts to land on Mars will likely stay there for many years, if not for life, because bringing them back to Earth is much more complicated than sending them to Mars. You'd need a rocket capable of lifting off from Mars and fuel for it. While launching from Mars is easier than from Earth and would require a smaller rocket, getting all of that to Mars remains complex and expensive. Building such hardware on Mars won't be feasible until we have full-fledged colonies with local industry. One likely approach is to use Falcon 9 class rockets to reach orbit and assemble a ferry ship, something like Ares from The Martian, that would shuttle between Earth and Mars, assembled in space using ISS-style experience. So, our astronauts have reached Mars and landed. What's next? What will the red planet greet them with? Mars's atmosphere is very thin. The average surface pressure is roughly 170 times lower than Earth's. It's mostly carbon dioxide, about 95%, with virtually no oxygen. Because of this, a person can't breathe that air or work on the Martian surface without a spacesuit. A simple oxygen mask won't work. Long-term stays on Mars require a sealed habitat, likely a dome, that maintains normal pressure and a breathable atmosphere inside. On the other hand, such a thin atmosphere can't seriously damage a colony during storms the way movies often show, for example in The Martian. The real hazard from such storms is dust. It coats every surface and abrades equipment, accelerating wear. The good news is that Mars has plenty of ice beneath the surface, reducing how much water we need to bring from Earth. Current missions continue mapping subsurface ice to help choose future settlement sites. Another challenge for colonizing Mars is its lack of a global magnetic field, though Mars does have very weak remnant magnetism from an ancient dynamo. Because shielding is weak, the surface is exposed to higher levels of cosmic radiation than on Earth, and cumulative exposure over many years becomes a major risk. There are several ways to address the radiation problem, and the solutions will evolve as the colony grows. At first, the plan is to place the living modules beneath the planet's surface so people can spend most of their time in a protected environment. As the colony grows and longer stays on the surface become necessary, the base itself could be shielded by a magnetic field generated by a sufficiently powerful electromagnet brought from Earth. And when it comes time to expand the settlement across the entire planet, the goal would be to cover all of Mars with a magnetic field. Right now, scientists are considering several ways to create a magnetic field that large. For example, we could lay a superconducting solenoid along Mars's equator and connect it to a powerful power source. Since this is a far future prospect, technology by then might make it feasible. Another idea is to place a powerful electromagnet at the Mars-Sun L1 Lagrange point, creating a shield that protects the whole planet from solar radiation. In these conditions, the first colonists would deploy the initial Martian base and begin building the colony. To do that, they'll need additional equipment to support life and work on Mars. Priority number 1 is the habitat module. It must provide sufficient protection from radiation and the thin Martian atmosphere, prevent dust and sand from getting inside, maintain comfortable internal temperature and pressure, recycle air and water, and handle many other functions. There are a few concepts for such a module. One is to build something like the habitat shown in The Martian, but more modest, and place it in a Martian cave. Several prototype concepts are being tested in Earth deserts and volcanic sites, though none are yet ready for real Martian conditions. In contrast, Elon Musk proposed that the spacecraft itself land on Mars and become a habitat, reducing the mass of materials sent and providing a radiation-shielded living module on the surface. Meanwhile, NASA is exploring a different approach, combining a habitat and a rover into a single vehicle. As soon as the first colonists move into their new home, whatever form it takes, they'll start deploying surrounding systems, expanding the settlement for new arrivals, and conducting research. To do that, they'll have to work outside on the Martian surface. We've said a person can't survive on Mars without a spacesuit, but current suits aren't ideal for extended surface work. They're cumbersome and heavy in Earth gravity and not suited for fine, delicate tasks. Because Mars has an atmosphere, heat exchange with the environment is more intense. So suits will need more advanced insulation, heating, and cooling to handle winter cold and summer heat. That means developing new suits, lighter, more mobile, and easier to maintain. NASA specialists have developed several prototype spacesuits for Martian conditions. For example, the Z2 suit you can see on the screen now. Some of them have already been tested by participants in the HISEAS experiment, where crews live for extended periods inside a sealed habitat on the slope of a Hawaiian volcano. Some materials are even being aged on Mars itself. Perseverance carries spacesuit material samples for long-term exposure tests. Armed with all these tools, the colonists would prepare the base for subsequent groups of astronauts. A key step toward a full-fledged settlement is transitioning to self-sufficiency. While building local industry will take decades, the colony must start producing its own food and water as soon as possible. Equipment can be shipped from Earth and maintained with spare parts, but food spoils and water stores are vulnerable to loss. Launch windows from Earth to Mars open about once every 26 months, so immediate resupply is impossible if something goes wrong. This means the colony must be able to operate autonomously for at least 26 months, and potentially longer if a resupply mission fails. That's why early crews are expected to bring hydroponic farms, with the longer-term goal of growing plants directly in conditioned Martian soil where feasible. We all remember The Martian, where botanist Mark Watney grows potatoes on Mars. Real life will be harder due to possible soil toxicity, but site selection and decontamination methods could help. Experiments on Earth with simulated Martian regolith show it can be made productive, so prospects for Martian agriculture are cautiously optimistic. Water can be obtained from subsurface ice. Ongoing studies aim to pinpoint deposits and assess what's required to use them. The final step toward genuine autonomy would be natural population growth. There's still no consensus on conception and healthy gestation in reduced gravity, and radiation adds further risk, so decisions about having children on Mars remain in the future. Before we wrap up, I recommend Stephen Petranik's book, How We'll Live on Mars, and the short docudrama series Mars from National Geographic. Both explore these plans and include expert interviews. That's all for now. If you enjoyed the video, hit like and subscribe to the channel. See you next time.